we have a pumpkin that's frozen and it falls from a certain height h, and that's what we actually want to find. And what we're given is its mass of 5.4 kilograms, the time it takes to stop, 0.02 seconds, and the force acting from the ground onto the pumpkin of 1230 newtons. So if we look at the pumpkin, when it hits the ground, if we just want to draw a free body diagram of the pumpkin when it hits the ground, we have the force acting upward from the ground that's stopping it of 1230 newtons. And we have the pumpkin's weight force acting down. Now, since we're given a time it takes to stop, this is an impulse momentum problem. We know we can use impulse momentum. F delta t equals final momentum minus initial momentum. So our force is given, our delta t is given. Our initial momentum from the pumpkin up here is 0 because it starts from rest. So all we're left with is final momentum we don't know. So we can say F delta t equals final momentum, which is mass times velocity. We know the mass, we'll be able to figure out the velocity, and if we know the velocity, we'll be able to figure out how high this pumpkin started out at. So force is 1230, delta t is 0.02. I'm going to divide m over here of 5.4. So the velocity that the pumpkin hits the ground at is 4.55, and 5 just repeats, meters per second. So now all I have to do to figure out the height that it started out at is I'll use conservation of energy. Energy initial equals energy final. So initially, the pumpkin's up here, it's not moving, it has no kinetic energy. V is 0, so all we have is gravitational potential energy of mgh. That's equal to our final energy, and at the ground we have 0 height, so we're going to call that 0 gravitational potential energy. It has all kinetic energy, 1/2 mv squared. So all we have to do is figure out for h. H equals 1/2. Cancel out the m's, we have v squared, divide g over, and all I need to do is plug in. V is 4.55 squared over 2 times g. So after plugging that in my calculator, we find pumpkin drops from the height of 1.06 meters.